Exercise 1.15, question number 1. Rewrite each expression using a root symbol. We know that 1 by 2, that is the value of the square root. Similarly, 1 by 3 is the value of cube root. Oh, 1 by 4 is the value of fourth root. And similarly, so on. 1 by n is the value of nth root. So when we need to convert it using the root symbol, so we just need to have it for part A. (25 raised to power 1 by 2). So when we will be converting it using the root for 1 by 2, I need to have its square root. Square root of 25. So this is the conversion of 25 raised to power 1 by 2 from index form to the root form. Okay, as now normally we can see that 25 square root, it can be simplified to give us 5. But since the requirement of the question is using a root symbol, so we need to retain our answer up till here. No need to simplify it in this case. Okay. Similarly, for part B, 3 raised to power 1 by 3. As I was discussing that 1 by 3 is equal to the cube root. So that will give me cube root of 3. Now for part C, this is 40 raised to power 1 by 5. That is fifth root of 40. Then part D, 6 raised to power 1 by 2. Again, for 1 by 2, I need to convert it to the square root. So that will be square root of 6. Then for part E, since I am having 3 raised to power 1 by 8, so that will be equal to 8th root of 3. For part F now, continuing on the same pattern, we can see that it is 2 raised to power 3 by 4. Since we know that mm, in case of laws of indices, whenever a number A has got a power n, let's suppose, and whole power m, means there are two powers of the same base. Both the powers can be multiplied, n times m. So I can use it in the reverse order. Okay, how it is it? Let me clarify. It can be written as 2 raised to power 3 times 1 by 4. Now, there are two powers, or the powers of this 2 are written as a product. For the root, its power should be 1 by 4. Means there 4 should be in the denominator. So I can split it into 2 raised to power 3. For this 1 by 4, I'm using this rule. So I can write it down 2 raised to power 3 whole raised to power 1 by 4. So that could give me 8 and then fourth root of it. Also, it could also be done in the other way around, like 2 raised to power 3 times 1 by 4. I can also change their order. I can write down like 2 raised to power 4 times 3. So for this 2 raised to power 1 by 4, I can have the fourth root of 2. And then for this 3, I can have its whole cube. So both of the forms are equivalent. So we can have answer in both the forms, no matter this one or this one. That makes no difference. Okay. In the same way, for part G, I can have using this format, I can have 12 raised to power 2 time 2 by 3. For this, 12 raised to power 1 by 3 times 2. I can write it like this as well. For 12 raised to power 1 by 3. 1 by 3, if it is in the power, that means it is the cube root of 12 and then its whole square. So I'm done with the required format of the root symbol. So that might be one of the possibilities of the answer. And for part H, similarly, 5 raised to power 2 by 9, I can write down 5 raised to power 1 by 9 whole raised to power 2. For 5 raised to power 1 by 9, I can have the ninth root of 5, and for this 2, that would be the same as it is. So that concludes question number 1. Now it's question number 2. Write each expression using index notation. So it's the reverse of that. For part A, now square root of 5. That means its power is 1 by 2. So that will give me this. For part B, this is the cube root of it. That will give me 8 raised to power 1 by 3. Since it is not required to simplify it, so we would retain our answer up till here. Okay. Then for part C, cube root of 13, that is actually 13 raised to power 1 by 3. For part D, you are having fourth root of 11, that is actually 11 raised to power 1 by 4. For part E, cube root of 9 and then its whole square. For cube root of 9, I can simplify it to 9 raised to power 1 by 3 whole raised to power 2. Now since that was the rule, a raised to power n times m, whenever a single base has got two indices, the indices are going to be multiplied. So it will become n times m. So now one power is 1 by 3 and the other power is 2. So I need to multiply both of these powers 1 by 3 times 2, which will give me 9 raised to power 2 by 3. Since no more simplification is required in this question, we just need to convert it in the index notation. So that is the answer. Had it been mentioned in the question to simplify it, so it could have been simplified further. Okay, then for part F, cube root of 6 whole raised to power 4. So that will give me 1 by 3 whole raised to power 4. Now again, the two powers would be multiplied to give us 6 raised to power 4 by 3. Then G, 32 raised to power fourth root of 32 raised to power 3, which will give us 32 raised to power 1 by 4 whole raised to power 3. Now again, two powers of 32, so we need to multiply them. 32 raised to power 1 by 4 times 3, which will give me 2 raised to power 3 by 4. And then finally part H, this one, 2 times fifth root of 12 whole raised to power 7. Don't get panic from this 2. 2 would be the same. For this, I'm going to have 12 raised to power 1 by 5 whole raised to power 7. Now, two indices for 12, that would give us 12 raised to power 7 by 5. So, that is the required format. You can have it either this way or 2 times 12 raised to power 7 by 5. Means index is for 12 in either of these two cases. Either this is the way or this is the way. Both are equivalent. So that is your answer to the last part H of question number 2. Now it's question number 3. Use a calculator to evaluate. Part A. 25 raised to power 1 by 2, 27 raised to power 1 by 3, and so on. So let's use calculator to solve it. So that will give us square root of 25, which is 5. So answer to part A is 5. Second part was cube root of 27. So we can have it in any of the ways like 27 raised to the power 1 divided by 3. So its answer is 3 using the calculator. So this is how you need to input indices. There are different calculators and their formats of the number input may be different, but normally this is one of the ways most calculators are calibrated. So this is how we need to do. So then for Next part C. Eight raised to power 2 by 3. Using the calculator, we can have it like, or with the, if I can simplify it using the calculator, you can have 2 raised to power 3, that is 8, 2 raised to power 3. There are two powers of the same number which can be multiplied. So that will leave the answer to 2 raised to power 2, which is 4. So that will be the answer using a calculator. So part D is 16 raised to power 3 by 4. We know that 2 raised to power 4 is 16 whole raised to power 3 by 4. So either you can directly cancel them out, or at the back end, what's going on, that's the law of indices. Whenever a base has got two indices, the indices get multiplied. So you can have cancellation of 4. So 2 raised to power 3, you are left with 2 raised to power 3 means 2 times 2 times 2, that is 8. So that's how part D is to be done. Then part E, 216 raised to power 2 by 3. Now we need to find out a number uh, which when multiplied with itself 3 times gives us 216, and that number is 6. So I can write down 6 raised to power 3 for 216 whole raised to power 2 by 3. Again, two indices of the same base means you need to multiply the indices, cancelling 3. So 6 raised to power 2, that means 6 times 6, that is 36. That is one of the manual ways of solving these questions. But since it is the requirement of the question to use a calculator, so you need to use the calculator as we have been doing in the starting parts of this question. Okay. For part F, this would be 0.125. I'm solving it manually so that I can explain the underlying steps to how to solve them. So getting rid of this decimal, I need to have 3 zeros in the denominator because there were 3 decimal places in this. So that's why I need to have 3 zeros in the denominator. So now there is a rule of indices. Whenever a fraction has got a same power, that same power goes for the numerator as well as for the denominator. So this is what I'm going to apply here. 125 raised to power 1 by 3 divided by 1000 raised to power 1 by 3. Now I need to have a number which when multiplied with itself gives me 125, and that number is 5. 5 raised to power 3 will give me 125 whole raised to power 1 by 3. And same goes for the denominator. The number is 3, which when multiplied with itself thrice will give me 1000. So now two powers of the same number. So I can cancel this with this and this with this. So I'm left with 5 in the numerator and 10 in the denominator. So further cancellation from the calculator will give me 5 ones are 5, 5 twos are 10, 1 by 2, that is 0.5. So that's how part F is to be done. Okay, then it's part G. 46 raised to power 1 by 2. Now, using the calculator, since uh, 46 is not a perfect square, so instead of using the manual method, I can show you using the calculator. So, square root of 46, that is 6.78. So, that's the answer to part G. Similarly, for the next part, which is part H, 125 raised to power negative 4 by 3. So I can have 125 raised to the power negative, then that was 2 by 3 or 1 by 3, I guess. So that would give you the required format, how it is to be done. So 32 raised to power 125 raised to power negative 4 by 3. 125 raised to the power negative 4 by 3. That is 0.0016. So in the same way, we can do the remaining parts. So that's it for this video.